So now that we have our movement working in our game, we want to be able to actually follow the player a little bit better. Because if we're running down our course here, then, well, our player is going to get very small and it's going to be very hard to actually do some jumping and land those jumps on these platforms. Well, I did it now, but anyway. So we're going to add a camera to this, and we're going to use Cinemachine. So let's go and install Cinemachine. Go Package Manager and then type Cinemachine, and then it will show up. Hit install and just let it run. So now the installation is complete, so we can go and add a camera. So let's go Cinemachine and then virtual camera, and then let's just move it up a little bit. And we are going to have a camera that follows behind the player, and it can have an angle of 35 maybe. So it will essentially follow the player in this direction, and we will use framing transposer and with a camera distance of 7, and then we will just leave everything as it is. So if we hit play now, we can see that our player is loaded, and it's this entity 2 here. So let's just manually have it follow this. So now that we are following the camera, we can see that it's much easier to actually control the character, and yeah. So this is the setup that we are going to use. The challenge now is that we need to, once we have added our entity, the camera needs to find that entity and attach to it for the local player and not other remote players. And we can actually turn this off. We're not going to use the aim. So we need to write some code for this. So let's create a folder and we'll call it scripts. And let's add a new C# script, player handler. And let's open that in Visual Studio. We need to be able to react to quantum events when our entity has been instantiated, and then we are going to assign the camera to it. So first of all, let's add using quantum and using Cinemachine. Then we can get rid of our start and update function. And we need access to the entity viewer of this object. So we're going to put our player handler on our Unity character controller. And that has an entity view on it. So we are going to use serialize field, get the entity view, and then we can actually use that. So we are going to react to an event. So on entity view, we can have an event called on entity instantiated. And I need to, there we go. And once this has been called, then we know that, okay, our object has been instantiated. So let's write that to our debug log. So we can write player, or actually player character controller, and then this. All right, so then we add to our log so we can see what's going on. And what we need to do then is figure out, okay, is this our local player? And how we can do that is using our player link that we added before. So we need to get our player link for this specific entity. So first of all, we need to access Quantum Game. So let's add Quantum Game, and it will be Quantum Runner default game. Then we have access to that. And through our Quantum Game, we can gain access to our frame. And the frame is containing our player link. So we need to be able to access our frame. And from that, we can actually try to get it. So we are going to do frame, try get, and then add in the entity ref that we're interested in. And then we are going to add our player link. So if there is a player link, this will become true and will execute. So once we have figured out that this object has a player link, then we will try to see if this is our local player. So there is a function for that actually. So let's do game player is local, and then we'll add our player link.player. So that will only come true on our local player. So that's wonderful. Then we know that this is our object. So then we need to assign our camera to it. So we will just find our virtual camera. So let's do find object by type, Cinemachine virtual camera. Then we have access to the camera. And then we will tell it to follow this transform. Alright, so that should work. So let's save that and go back into Unity. Now let's go to resources and find our player character controller entity. And let's add our script to it. There we go. And then we need to assign our entity viewer. So let's drag and drop it, the object there. And then we need as well to trigger this event that we had. So we have events here on entity instantiated. So let's hit the plus sign. Again, add our object. And then we have player handler. And we have our on entity instantiated. So let's save that. And then we can actually take it for a spin. Alright, so now we have been instantiated and we are actually following the correct object automatically. So yeah, that was fairly easy. So let's improve how our player looks a little bit, but first let's create some new materials. And we will add some eyes to our player. So let's do a white material and just make it white. And then we'll do a black material called black. And then go to our character controller and turn off our gizmos. So this is how our player looks like right now. And forward is in the blue direction. So we want to add some eyes to it, and let's just duplicate our sphere here and move it forward, and we'll make it white like some eyeballs, and then we can scale it down, so something like this maybe. Move it up a bit to the edge. Maybe it was a bit too big to be an eyeball actually. So let's make it a little bit smaller. That would be good. And then we will duplicate this, add this as a child, and then assign black to it, and resize it and move it forward. That will be good. So let's just call it eye. Duplicate it, and all right. So there we have some eyes to our character. And if we save it now and take a first spin, we can see that we are not seeing the eyes because our character is actually not rotating. It is always facing forward. So we want it to face the direction that it's moving in, and we need to change our code in Quantum for that. So let's go Quantum, open Quantum project. So let's open our movement system. And after we've moved the character and jumped, we want to rotate it towards the direction that we are moving in, which is the same as the input keys. So first of all, we need to check if the input vector square magnitude is 0. So if it's providing 0 input, then we can't use a rotation because that produces a mathematical error. So it needs to be something for us to be able to rotate it. And then we will do it sort of like you do it in Unity. We will change the rotational object. And for that, we are going to use a quaternion. So we are going to add FP quaternion, and then it will be a look rotation, which takes in a forward direction, which will be the same as our input vector, and we use our XOY, and that will cause our player to instantly rotate in the direction that the keys are pressing. But we want to do it a little bit more smoothly, so it doesn't like from one frame to another move from like the right direction to the left direction. So we want to make it a little bit more smooth, and we can do that just like we do it in Unity. So let's add a lerp to it. So then we'll use FP quaternion lerp, and it will take in a direction from to as our regular lerp. So let's do the rotation that we have right now to what we want to look at, and then over a time parameter. So let's take our f delta time, and then the delta time is a little bit slow, so I think that if we multiply it with maybe 10, it should be enough. So that will cause our player to smoothly rotate its direction. And while we are changing our code here, we can as well add a respawn code. So if right now a player is falling outside the map, and it will just continue to fall in eternity, but we want it to respawn. So let's check we'll just do it in a very easy way. So we will check if our transform's position is less than -7. In that case, we are going to respawn it. And before we respawn it, let's add something to our log. So we can do log debug, which will write in the Unity's console. So we'll add quantum before it, so we know that it's actually coming from quantum. And player fell too far, respawning player. And we will just take our player, and we will take the transforms position, and then we'll use the same code as we had before, get spawn position, and provide it with our player link. So that will respawn the player. So let's build, and now we can try it in Unity. I've built 2 clients from this, so let's take it for a spin using those, and let's change the name of the second one, and then we'll hit start game. So we can see that, okay, we have a guy, and we can see that his eyes are rotating in our direction that we're moving, so that's good. And we can also move the other character around, and if we go outside of the map, it will respawn, and the same with the other player. So that's good. Our respawn code is working, but we still have the same issue that we had before. So if our other guy here, if he leaves, then he will remain in the game. So this is not something that we want. We want this other player to actually be removed whenever you're disconnecting. So that's something we need to fix. So let's go back into Quantum. So open Quantum project again. So we're gonna hijack our movement system for this, and maybe it should be another system, but we're gonna reuse this anyway. So we're gonna add eye signal on player disconnected. So we're gonna react to that, and we are going to implement this. So let's implement interface. And so now we have it here, and what we need to do is we need to figure out, okay, which this will be called on all our movement systems. So we need to figure out, okay, which of the objects are we going to remove. Okay, so because we're getting an on player disconnected, and we're not getting it for the specific entity, so we need to filter out that it's actually the correct entity. So how do we do that? Well, we are going to check, we're going to do a for each loop then, and we are going to do it with our player link, and we are going to get component iterator from our frame. So then we have our variable here, player link, that we can check if it's the correct one. So if the player link component player is not equal to our player here, that means that it was not the player that disconnected, then we are just going to continue. If not, we are going to add again to the log on player disconnected, player destroyed, and then we are going to do a frame destroy player link and the entity of that. So this will cause that player that left to be removed from the game. So let's build and then go back into Unity. So again, I've built 2 clients, so let's hook them up and start game. Okay, so now we have our character here and they are working, and let's just see that respawn still works. Yeah, and let's disconnect this client. So now it actually disappeared from our game. So that's awesome. Now we have our players working. Now another limitation that our game has is that it only supports 6 players. So if we go into our Quantum debug runner, we can see that okay, we have 1 player here, but let's add 7 players. So now we have 7 elements. So if we would hit play now, we will see that it's going to complete our domain here, and we have an error saying that okay, invalid player count, it needs to be between the range 1 to 6, but we want to have more players. So how do we fix that? Well, we fix that on the Quantum side, and it's fairly easy. So let's open our Quantum project. So we need to add a QTN file that defines how many players we should have. So let's add a new folder, add folder, and we'll call it game logic. And in there, let's add a QTN file, game setup. You can call this anything really, but we'll add a game setup QTN. Okay, and then we do define player count 20, pragma max players player count. This will set the player count to 20. You can set it to any number you want that for your game, but let's use 20. And then we will build our solution and go back into Unity. So if we take our debug runner, increase the player count to 20 and hit play, we should now get 20 players. And we did. Actually, they are spawning outside of our map, and they're actually not centered, so our spawn code is probably not the best. So how do we fix this? Well, first of all, this needs to be a little bit wider so that we can get in all players. I think if we double it in size 60, that should be fine. But then we need to change our spawn code so our players are actually centered. So let's fix that. Let's open our Quantum project in Visual Studio. So if we look at our movement system, we can see that, yeah, this is the reason why it's not centered, because, well, we don't know how many players there are in the game. So for us to be able to actually center it, we need to know how many players there are. Oops. So we need a int player count for this to work. And we need to know the width, how much size does our players take up in total. So let's add that. Width of all players, we'll take player count times 2. And then we need to change this code. Let's see, -4, no. Player number times 2 plus 1, yes. But then we as well need to move it to the left with how many players do we have? The width of our players divided by 2. So then our players should spawn in the center. But now we need to provide our player count here. So how do we get that? Well, it is included in the frame. So frame dot player count, and the same here. So let's compile this. Build. There we go. And now we can try it in Unity. So let's as well change our course a little bit so that we get some more obstacles in the start. Stuff like that. And yeah, we'll keep it as it is. And then we can hit play. And our spawn should hopefully work. And we are going to be, well, the last player. So if we look at our scene, it is centered. So that's good. Let's group some of these together. There we go. Now we have a bunch of them that we can play with. All right. I'd like to give a shout out to our Patreon supporters. It helps us with every single contribution that we can get. So please consider supporting us on Patreon. The link is in the description. This concludes this episode, and I hope that you enjoyed it. If you did, please give it a thumbs up and hit that subscribe button and the bell to get a notification when the next video is out.